Hello guys, April 5th. So okay. So last week we've seen this service action, topic. We managed to complete the service, and so I'm gonna quickly complete this action versus service today. Not much time, and then I will show you. I bring a sensor. This is a RGB-D camera. So I'm gonna show you as an example how to connect a sensor to the any ROS devices. It can be anything, laptop or any computer or NVIDIA, Jason, whatever. I just want to demonstrate how things will be easy, okay? And then if time permits, I'm gonna show you this a Husky unmanned ground vehicle. Obviously we don't have a physical robot simulation, and yes, maybe that's it. And then maybe next week, since all these part 1 to 3, they are all text based, so little more interesting example using a turtle sim. You will get a basic concept how to control. This is not a real robot, okay? As the name implies, this is turtle simulation turtle. But if you replace that turtle sim with a actual robot, it's pretty much the same to us, okay, as a programmer. So that is the next week plan. So this week, let's complete this action. I think that's the part 3, right? The second part of the part 3. Here, right? Am I right? No? Don't remember? Or did we finish this? Fibonacci? Did we? Yeah, okay, maybe, yes. I remember, okay. No, we didn't, right? I don't remember. We see this Fibonacci action, right?
I think we did, because you were talking about the future, and like you had to do the while loop to wait till the action responded. I think that was in this one.
Maybe it was like, I think we might have like gone over it like
yeah, not actually, yeah,
actually
exactly, not actually started. Yes, we can check. This is a Fibonacci action server. Let me see. We have a Fibonacci here. See, that's nothing inside Fibonacci, right? Okay, I believe you are around here. Let's see. terminal whenever we go to ROS2 workspace. Don't forget to this setup stuff, right? Okay, now environment are set up for ROS2 workspace, and ROS2 interface. See, we don't have this action. Yes, that means either we did not build, okay, or ROS2 interface show the see. Yep, don't think we built, we installed, I mean we implement this. Okay, going back. Okay, so we created this package Fibonacci for this action test, and Fibonacci under the SRC Fibonacci, meaning we created this package at least, okay, and let's create actions inside source, okay, under the ROS2 workspace source Fibonacci. We need actions folder. So again, either you could use this tool, Visual Studio Code, like using this new file, new folder, or okay, again you can just go to the terminal. Let me clean this up. So okay, I'm using this terminal. So we may again go to SRC, Fibonacci, and mkdir actions. Okay, you can follow this route, or again you can just do here using actions. Okay, so we don't need this. Okay, next one, create action definition. That is a, I believe, typo, either this one or this one. Actions and action, I don't know which one is right, but I need to create Fibonacci action file. gedit means the editor, default editor. So Fibonacci actions, new file, name Fibonacci action, and then edit that one. 3 dashes, that's a new line in the in this definition. Okay, int 32 order, int 32 array sequence, int 32 array partial sequence. These three are the action, Fibonacci action. So save this, and next one we need to add this package, which is action Fibonacci action. That implies this should be action, not actions. Okay, this one. This find package and generate interface must be inside CMake. There are many CMake list.txt, so you have to identify the exact one under this guy. Okay, and right before the amend package, right there. Okay, save, and package.xml, which is this one. We got to add these 3 lines. Build tool dependent, so this must be right here. You can put anywhere, but better to put in the same location. And depend action messages, which is since this is a new, I can add anywhere. And then number of group, which is saying what happened. Okay. It doesn't like my copy and paste, so I don't know why. Okay, member of group, ROS ID L, not default generator, interface packages, and number of group. Okay. Oh, no wonder. Shoot. Okay. Same thing. Okay. So we change package.xml and cmakes.txt. Again, you can go back and forth your terminal, or like we have a terminal here. I can do, I'm at ROS2 WS, so Qualcomm build. So let's see if there's no typo or anything. I should be okay, successful. And as you can see, these are previous add integers and then talker listener, add integer, talker listener stuff. So I can identify a particular package only to build, but when I just say build, it builds everything. Okay, everything good. Okay, now let's see if this is working. So again, don't forget to do source Okay, and then ROS2 interfaces, interface show Fibo, yes, okay. That is my definition, right? So everything is good up to this point. And then we need to create a finally Fibonacci action package. Okay, so again go back to SRC, package create. So make sure you are at ROS2 and package. This is a one single line actually. Then package created inside the SRC, which is Fibonacci action. Ooh, shoot. Okay, you did. You saw, right? I messed up. I'm gonna delete this again. I should be inside SRC. Same mistake over and over again. Because I created a Fibonacci action, was not able to find it, so it was okay. Anyway, now it's inside my ROS2 and SRC and Fibonacci action. Fibonacci action. Okay, cool. And then let's write a Fibonacci action server. Okay, action server. That means a cd change directory to Fibonacci action, which is Fibonacci action here, right there. Create gedit means again this is the editor. Edit this one, meaning you gotta create this file, new file. It's a new Python program, and then don't copy and paste, as I said. Type. Okay, this is my action server. Again, this is just a class, Fibonacci action server class, constructor, and when you create action server class, this is a instantiation of an action server, giving these names with this callback function again, and this execute callback is a member function of this Fibonacci action server. So whenever this Fibonacci action server needs to do something, this function will be invoked. So all you need to do in your main is just initialization, ROS client library Python, and then create a Fibonacci action server, and then again spin. Okay, to make a main infinite loop. Okay, that is it. And then let's add a entry point. Again, entry point is in the setup.py. Make sure you are at the same folder. Okay, here console script is this guy. Okay, make sure you have the same entry point, console script, and this one. Okay, see. What does that mean is, this Fibonacci action. It's a setup.high. It points the location of this action solver and function. So inside here, find this one, okay? And then build and run. Before we build, check the dependency again. Since I am using Foxy instead of Galactic, so you should not use this Galactic, but you could use this ROS distro environmental variable. Okay, so what I can do is like and then this is default yes, but hopefully everything is already done. This guy is missing, right? We should be in the workspace, not inside SRC. Okay, everything, all required dependency installed already. So let's build it again. Call con build. Success. Again, don't forget to source install setup. This is actually one difference from ROS1. ROS1, everything is not installed, but inside my workspace folder under the devel. But from ROS2, as far as I know, default is installing to the system. So that is why we do the source install setup.bash. It used to be source devel setup.bash in ROS1, but ROS2, this is something you gotta do. Then you can run this one, ROS2 run Fibonacci action, and then Fibonacci solver. Okay, to check no attributes. Did I save? Maybe I didn't save it. Okay, setup. What am I missing here? That is right. Really? To run Fibonacci action solver. So there's no attribute main. no attribute main means I don't have that one. Maybe the name is not right. Fibonacci action server node, and there's a name. Should be right. Okay. What does this mean?
It's the same problem again.
Fibonacci action server node name. That's right. Yes, same problem.
Did you include your messages in the package.xml? That might be the issue. I think it would just be Fibonacci, I think you called it.
Fibonacci. Nope, we don't need add anything. This is for Fibonacci action. Not.
Yeah, you should have to include that message package, the Fibonacci message package, in your in the package.xml of the action server. If you don't do that, sometimes it spits out weird errors like that, at least in C++. So I think it's just called Fibonacci is the package name. So if you just put like XML depends Fibonacci, I think that might link. This is fine. I think it's just your Fibonacci action package.xml. I think you just need to put depend Fibonacci.
Where?
Inside Fibonacci action folders.
Here?
Package.xml. The bottom one, Fibonacci action.
Fibonacci action.
Yeah, that package.xml, that directory. Put,
This one?
under RCL Pi, put depend Fibonacci. Because in your package.xml you didn't have a dependency on the messages you made for the action server, and that was in the Fibonacci package, I'm pretty sure. So I think that might be
This one?
Yeah, because that might change what packages are copies to the install directory, which may be how you're getting that.
Okay.
Aha. It's a server, so it's not
Okay.
doing anything, but it is working.
Then now we can do this one.
Yeah.
So now its action server is running. So we can open another like terminal and do this setup again and do this ROS2 action send go. And then feedback Fibonacci action Fibonacci and order 5.
I think you messed up the spelling order, yeah.
What? Which one?
Order was misspelled, but I think you missed an argument.
Thank
It
you.
didn't work.
I think that may be an outdated command, potentially. That may have been one of the differences between Foxy and Galactic, I think.
Oh,
I've definitely done this before.
Let's see.
We can figure it out, I'm sure we can just check what the command doc says.
The dash is not that dash.
Oh, yeah, that's probably what it is.
But I was Fibonacci action Fibonacci order 5.
You might need a
okay, maybe
space.
no space here, right?
Yeah, I think that's what it is. You might need 2 dashes. Yeah, you need 2 dashes.
Yes.
There we go.
Okay. That is 2 dashes. Okay, 2
Oh,
dashes.
it's 2 dashes into Unicode.
Yeah, and convert
That's
it
the
to like a
question.
long dash. So okay, so that was copy and paste didn't work. Anyway, this is a simple example of Fibonacci server in Python, which is boring, right? So okay, so we have done this then the last part of this one is a Fibonacci client node. Let's complete this one. So again, go to the Fibonacci action folder and then create this client node. Simply go back here, new file, this with this name, client, copy, paste this. Okay, and save. Add the client line as well. in the setup.py right here. So make sure we got everything. Client node name, yes, okay. Yes, and then we can see action server is still running here. Let me use then the other terminal. Check this dependency again. Just ROS2. I mean, this is not necessary, but again, oops. Install, no install. Okay, everything is good. So call con build. So now including Fibonacci action client. So now I can do setup bash and this setup. Server is running there, and then let's run this client. Every time. What happened here? Then nothing. Package. We got it. Nothing. What happened? What? Why? Oh, what's the error? No executable found. No executable. No executable.
Try tab composing it. Same compliance.
Ooh, client is not there. Why?
It didn't. You resourced, right? Yeah, you resourced.
Yeah. Client right there. Fibonacci action. Client. Yes. Really.
Oh yeah, so those messages are kind of like what they're for. If you have if you're sourced install and you're rebuilding, it thinks you're trying to build over your install. So it's just saying if you source two folders at the same time, if you source two installs at the same time, then it breaks. That's all it's warning you. So as long as you keep sourcing the same install over and over again.
That's okay. Okay.
So that warning doesn't really matter.
So it doesn't matter, which means we should be able to find. No.
It's just not happening.
Are you serious? Only server?
Check your setup, like conquer stuff. Because you got, I think that's probably. Yeah, that's right. Go to setup.config. Not sure if that's. No, that's fine.
Should be. We added this.
Yeah, it's fine. That's just depending on the messages.
Really? Really? Okay.
Yeah, it's worth a shot.
Yep. Okay. strange. Okay, but that's boring, right? So let's figure that out later. But this is very common when we use ROS, any kind of packages. Things are always happening, so we should be get used to anyway. Okay, and back to the original plan. I'm gonna show you how to use this Realsense. Okay, this Realsense 2 camera is from Intel. The name of the, where is the sensor? Where did I put the sensor? Oh yeah.
Oh.
Okay. That is the sensor. Realsense.
Is that a D435 or D435i?
D435, not I. D435, yes.
That's what we use on as a, yeah.
So, this is driver, the ROS driver. Okay. So okay, let's assume you got this one and you wanna see what's going on. This with ROS. Search this index.ROS Realsense 2 camera. This is ROS2 wrapper. Installation instruction. Install latest Realsense SDK. This is for Jason. And this is Linux Debian installation guide, which is for us. Or build from source. Again, when you have package, it's much better to go with this package. This is from source. You can obviously build. Okay. Same workspace, right? Okay. Don't need to build. Debian installation guide. This is it. What you need to do is register this server's public key. Copy up to this point. Okay. In my case, I already have this. And then next one, what this line does is adding this URL to my apt repository. Okay, so meaning when I type apt and try to search packages, obviously there are some default Linux package repositories, but like this case, the Ubuntu guys cannot manage everything outside in the world, right? So anyone who wants to give this repository to a system, they can do this way. So this live Realsense intel.com, which is Intel's URL, and Debian apt repo, that's his repository address. So I got that one, and now you can install these packages without taking these two steps. When you type like a sudo apt install, by the way, apt get is the from 18. Apt get is apt now, so you don't have to type apt-get. Just say apt, and then install live real Realsense, okay, if I didn't do these, I mean, two bullet points, you are not gonna get this auto complete, okay? And then what? DKMS. In my case, I already installed. And next one is utils. Install. Then these two are optional. Okay. And this is a phone install. So how do we know this is properly installed? There is a tool from Intel, Realsense Sense Viewer. Okay, by the way, this is not ROS. This is just Intel's viewer program. Okay. So RGB depth. This is depth camera. So blue is close, red is farther, and black means don't know the depth. Okay, that's the outside of this depth range.
Black means there's another depth.
No. There is a maximum depth you can measure. Black means I don't know.
Okay.
That's too far. I mean, black means just too far. So like here, right? Okay, then all the SDKs are properly installed. Then now the next step is, since I got everything here ready, and then let's start a camera node. So ROS2 launch, Realsense camera, and RS launch.
It's working. It doesn't launch ROS, so you can't visualize it yet.
Okay, we can check the topics, and then we can again maybe another launch file has a
What are you looking for? I know these launch files, unfortunately, well.
yeah, I was looking for the RV's launch, but maybe not. Okay, but I can do it. So just start RV's, and you can add by topic, color, image. Okay. And I can also add a depth image, which is it's not pretty, but just grayscale.
You're using the exact same one? Like the same one?
Yeah, that's the exact same model camera.
Okay, as you can see, I didn't do anything. I just install SDK, and then yeah, now I can use it because I can show you. So ROS2 topic list, and these are the topics. that are publishing right now. So for example, like this image elect row, I can see ROS2 topic echo, camera, depth, and image elect. So whatever that is values from this image. So like if you want to do something, what's depth, color, image row. This is the RGB image data. If you want to do like a edge detection, whatever you want to do with this image, you can deal with this. You can write a ROS node creating a subscriber, subscribing this particular topic. Then your subscriber callback will get this data. Then you can process that image. Okay. Also another tool I can say is do you have an RQT2 or RQT?
It's RQT underscore graph.
This,
The ROS2 one anyways.
yeah,
That's fine. It works.
yeah, we can change. This is the image view. I mean, RQT is like a combined tool. Image view, I can add more plugin. This is a completely different program, but as long as you can subscribe this topic and then consider that one single data as an image and then just try to display, then you can see it. So this is a depth image. Yes, that was it. Just to show you any other sensors, joystick, for example, we can attach, and then we can display with these tools, or we can use those joystick values like buttons, ups and downs, left and right. And again, same thing, you can write a ROS node subscribing that joystick topic, then you can control. Okay, that is it for today.